Let's start our third hour lecture, that is inverse functions. There are 4 learning outcomes you have to achieve towards the end of this lecture. First, you must know how to show whether a function has an inverse and find the inverse of the function. So, second, compute the inverse of a function. Third, identify the domain and range of an inverse function. And lastly, you have to know how to sketch the graph of the function of f and its inverse f on the same axis. Let's say we have figure A shows the mapping of a function for the domain 0, 1, 2. And function f is 1-to-1 function, so therefore the inverse mapping in figure B is called the inverse of f. So let's say the f of x is x plus 1. So from 0 it will map to 1, from 1 it will map to 2, from 2 it will map to 3. So in figure B, if 1 map to 0, 2 map to 1, 3 map to 2, so this is in figure B is the inverse of the function f, where from 1 to 0 the function is x minus 1. 1 minus 1 will become 0, 2 minus 1 will become 1, 3 minus 2 will become 3 minus 1 will become 2. So to verify that f inverse is the inverse of f, we have to show that f of f inverse is equal to x, or f inverse of f is equal to x. So this is the method to find the f inverse. The inverse of a function f exists if and only if f 1-to-1 and onto function. So how to show whether a function has inverse or not? So we have two methods. So it's either use graphical method, and then we have to use horizontal line test to test whether the function is 1-to-1 or not, or we can use algebraic method, so where we have to let fx1 equal to fx2 and it should imply x1 equal to x2. Let's look at this example 20. So determine whether a function has an inverse and find the inverse function for each of the following function. So to determine whether a function has an inverse or not, so first of all we have to determine whether this one is 1-to-1 function or not. So to determine whether this function or this function is 1-to-1 function, so you have two methods as I said before. So it's either algebraically or you can use graphically method to determine whether it is 1-to-1 or not. Substitute f inverse into the function f, then you will get f inverse of x minus 3 over 2 is equal to x. So you simplify this and finally you will get f inverse of x is equal to 2x plus 3. Now let's look at example B. So you are given fx equal to 3x minus 1 over x plus 5. So with condition that x not equal to negative 5. So to determine whether this function has inverse or not, so you have to determine whether it is 1-to-1 or not. So same as A, so you have to let fx1 equal to fx2. So you will get 3x1 minus 1 over x1 plus 5 is equal to 3x2 minus 1 over x2 plus 5. So now you have to simplify this one. You can cross multiply 3x1 minus 1 multiplied by x2 plus 5 and 3x2 minus 1 multiplied by x1 plus 5. Now you have to expand this one and simplify. Then you will get as this: 3x1 times x2 plus 15x1 minus x2 minus 5 at the left hand side. At the right hand side, you will get 3x2 times x1 plus 15x2 minus x1 minus 5. So you can cancel off. So you will get as this. And finally, you find out that x1 is equal to x2. So we use the same conclusion as this. So since fx1 equal to fx2 implies that x1 equal to x2, so therefore fx1 is one-to-one function and has its inverse. So now you can find the f inverse. So you use f inverse is equal to x, and then substitute f inverse into the function, and then you simplify this one until you get the answer of f inverse. So I hope you can continue this on your own.